Hello guys, let's start with another problem which is known as find the middle index in array. So guys, what is given to us? We are given with array nums and we have to find the leftmost middle index, that is the smallest among all the possible ones. And what is a middle index in an index? Where the leftmost array sum is equals to the rightmost array sum. At that particular index, if the leftmost sum is equals to the right right array sum at that particular index, we have to return that index. And if middle index is equals to 0, the left sum is considered to be 0. Similarly, if middle index is equals to nums of length minus 1, the right side sum is considered to be 0. If leftmost middle index is not present, then we have to return minus 1. Okay, so for example, in this case, what we have to do, let's take an example. Let's take left sum. So left sum is 2. The question is very similar to the yesterday's question, that is to find the pivot index. That's we have to do. So you are getting how we are calculating the left sum array. Basically, we are adding from the left hand side of an array. We are adding the nums value from the left hand side of an array and storing into a new array which is known as left sum array. So for the first index, it would be nums of 0 only. For the second index, it would be left sum of i minus 1 plus nums of I. So 2 plus 3, that is 5. Again 5 plus minus 1, that is 4. 4 plus 8, that is 12. And at last 12 plus 4, that is 16. Got it? What about right sum? If we are calculating right sum, it would start from the right hand side of the array. So it would be, the last index would be 4. 4 plus 8, that is 12. 12 plus minus 1, that is 11. 11 plus 3, that is 14. And 14 plus 2, that is 16. Got it? So as you can see, our total sum of array is 16 in the left hand sum as well as in the right hand sum array. Get it? So what would be our middle index? The leftmost middle index. If I talk about indexing, it would be starting from 0, 1, 2, 3, 4. As you can see, left hand sum and right hand sum, we compare from the 0th index. Left hand sum is 2, right hand sum is 16. It doesn't match. Then we increment our indexing. Left hand sum is 5, right hand sum is 14. It doesn't match. Then we increment our indexing. Left hand sum is 4, right hand sum is 11. It doesn't match. Then we increment our indexing. Here, left hand sum at the third index. Left hand sum is 12, right hand sum is also 12. These two matches. So what would be our answer? Our answer would be index 3. Got it? That's what we have to do. It is similar to the yesterday's problem, that is to find the pivot index. Okay, let's try to solve it. What we'll take, first of all, we'll take out the length of the array nums. Then we create two array, that is to store the prefix and suffix sum of the array, that is left hand sum and the right hand sum of the array. We are following the basic approach or the minimal approach, that is prefix and suffix sum array. So we are making the prefix and suffix sum array. So let's make the prefix array of size n and prefix of 0 is equals to nums of 0, as it is the rule that prefix sums 0th index is equals to the nums of 0 for which we are calculating the prefix sum, and suffix sum of nth minus 1 index is equals to the nums of nth minus 1 index, as we are calculating the suffix of that array. Okay, so let's try to fill other elements in the prefix array from 1 till n. What would be the logic? That prefix of I is equals to prefix of I minus 1 plus nums of I. Yes, that is logic. Now make suffix array of size n, and we'll define suffix of n minus 1 index is equals to nums of n minus 1 index. Got it? This is the predefined condition for filling the suffix array of any array. Now start the loop in reverse order from n minus 2 till 0. Fill it such that prefix of I is equals to, suffix of I is equals to suffix of I plus 1 plus nums of I. Okay. At last, we'll compare our array, both array, prefix sum and suffix sum. So it could be around from 0 to n, and if prefix of I is equals to suffix of I, then return I, otherwise return minus 1, as it is told here that return the reference index that satisfies the condition, or return minus 1 if there is no such index. Got it? So what we are doing, first we are taking out the length of the array, then we are making prefix sum array of size n. To prepare the prefix sum array, or to fill the prefix sum array of the nums array, we have to initialize 0th index with nums of 0. We did it, and now we fill our prefix array using the nums array. Then we created the suffix array, and we initialized our suffix of n minus 1 with the value of nums of n minus 1. Now we fill our suffix array such that suffix of I is equals to suffix of I plus 1 plus nums of I. At last, we compare our both the prefix and suffix array. If at particular index prefix and suffix array matches, then we return that particular index, otherwise we return minus 1. Let's try to run it. See, it is working absolutely fine. For the first index x we have calculated, it is returning 3. For the second case, it is returning 2. Okay, for the third case, it is returning minus 1, because while adding the prefix and suffix array, we didn't get the middle index, so hence it is returning minus 1. Let's try to submit it. Yeah, it is working absolutely fine. It got submitted. So what could be our space and time complexity? Guys, see clearly. Space complexity is big O of 3n. Why? Because we are looping around n times, we are looping around the array nums 3 times. Why? First, to create the prefix sum array, second, to create the suffix sum array, and third, to compare them. The comparison is very important because that's how we return the index of the middle index of the array. Got it? So it would be big O of n. What about the space complexity? Space complexity is big O of 2n because we are creating two arrays, prefix array and suffix array, okay, of size, both of size n. Hence the space complexity is also big O of n, because big O of 3 and big O of 2n, here 2 and 3 are constant, so space and time complexity both are big O of n. Got it? That's it. Apart from that, please like and subscribe my video, and if you are watching whole video, try to solve the quizzes as well as, okay. And guys, wishing you a very happy Holi. That's it. Bye bye.